In this video, we will learn what regular expressions are and how to work with them when programming with C++. The acronym REGEX stands for Regular Expressions. It is used for pattern matching, commonly for coding find and replace functionality with strings. The first step to working with regular expressions in C++ is to include the regex header file at the top of the program. Let's look at an example of how regex can be used. We will start out by creating a variable of type string, named s, that we assign the string value of Batman. Next, we will create a variable of type regex named pattern. Inside of the constructor, we pass in the string of the pattern we want to check. For example, this is how we would check if the string starts with the word bat, followed by any other characters. To check if a match was found between the string and the pattern, we can use the regex match function. For example, let's use an if statement and check if there is a match by calling the regex match function and passing an x as the first argument and pattern as the second argument. Inside of this if statement, we will output the string match to the console. When we run the code, notice that match was printed to the console since the string Batman does start with the word bat. In this video, we will learn what linked lists are and how to implement a linked list using C++ code. A linked list is made up of nodes. The first node in a linked list is called the head, and each node in the list points to the next. Each node contains some data like a value, as well as a pointer to the next node in the list. A linked list is referred to as a singly linked list if the links to the nodes are in one direction. Sometimes, a linked list has links in both directions, so each node also has a field called previous. We call this type of linked list a doubly linked list. The C++ standard template library has built-in collections for these two types of linked list. The forward list container is a type of singly linked list, and the list container is a doubly linked list. We will learn about each of these in the next section of the course, where we learn about the main container types in C++'s standard template library. The first step to creating a linked list in C++ is to create a node class. This class will have two public attributes, one of type int named value, and one of type node pointer named next. Inside of the main function, we will start out by creating a node pointer named head. Then we will have a node pointer named first that we set to a new node. We will also have a node pointer named second that we set to a new node, followed by a node pointer named third set to a new node. After that, we will set the value of first to 1, second to 2, and third to 3. We will set first's next pointer to second, second's next pointer to third, and third's next pointer to null. Then we will set head equal to first. While head does not equal null, we will output the value of head to the console, followed by an arrow formed by using a dash and a closing angular bracket. After that, we will set head equal to its next value. At the bottom of the function, outside of the while loop, we will output null to the console, since the final value that a linked list points to is null. When we run the code, notice that our linked list is made up of nodes 1, 2, and 3, and that 3 points to null, signifying the end of the linked list. In this video, we will learn about trees in C++. A tree is a hierarchical data structure. It is made up of nodes. The node at the top is called the root node. Each node can have one or more children. At the bottom of the tree are nodes that don't have any children. We call these nodes leaves. There are many types of trees in computer science, including binary trees, trees where each node has no more than 2 children, binary search trees that have higher values as right children and lower values as left children, and tries, trees with nodes that store letters and branch into different words. Let's learn how to implement a tree using C++ code. First, we will create a node class that has 3 public attributes, an int named value, a node pointer named left, and a node pointer named right. Then we will go inside of the main function. Let's create a node pointer named root that we set equal to a new node object. We'll also create a node pointer named leftChild, set to a new node, and a node pointer named rightChild set to a new node. We will give root a value of 2, leftChild a value of 1, and rightChild a value of 3. After that, we will set root's left attribute to leftChild and root's right attribute to rightChild. Then we will output the tree to the console. Let's output a few empty spaces and then the value of the root. After that, we will output a new line, then a /, and then 2 backslashes. One of these is needed to escape the other, since backslashes are used as escape characters. Next, we will output a new line, then the value of root's left attribute, then some spaces, and then the value of root's right attribute. When we run the code, notice that a tree diagram is output with a root of 2, a left child of 1, and a right child of 3.